Okay, so this is trial number 2. What we're doing right now is we're going to solve a question or two, or maybe just one, from chapter 3 of the thermodynamics textbook. हमने पिछली क्लास में, and of course I guess a reminder is due because it's been so long, क्या किया था कि हमने pressure versus temperature, temperature versus volume and pressure versus volume के कुछ graphs बनाए थे और उसके बाद उन तीनों graphs को जोड़ा था आपस में to create this weird solid 3D surface. And then we focused on thermodynamic tables, जो कि आप लोगों ने बाद में carry भी करनी है, जो कि मैंने upload किए थे. The first thing that we started with was creating a temperature versus volume plot for, let's say, liquid water, जिसको हम आहिस्ता आहिस्ता गर्म कर रहे हैं, ठीक है? At, let's say, 1 atmospheric pressure. So what happens here is that your temperature is going to increase from 20 degrees to 100 degrees, and the volume is also increasing. उसके बाद when phase change होगा, तो you can imagine कि temperature is not really going to increase until things boil completely, right? So you're gonna have a constant straight line at temperature is 100 degrees while the volume is increasing जब तक boiling हो रही है, और उसके बाद जब boiling complete हो जाएगी उसके बाद you're gonna um, see a increase in temperature once again. Okay, so इस तरह के series of plots अगर हम बनाए different pressures पे, तो we figured के the difference between saturated liquid, which was the point where boiling started, and saturated vapor, which was the point where it ended, grew narrower until you got to the critical point where the distinction between the two pretty much disappeared altogether, right? Next thing we did was we connected all of those lines के जहाँ पे saturated liquid शुरू हो रहा है और saturated vapor, बन रहा है, and it created this dome-shaped plot. और ये प्लॉट आप लोगों को याद रहना चाहिए अगर आप लोगों ने इस कोर्स में कंटिन्यू करना है, ठीक है? सो दिस इज टेम्परेचर वर्सेस वॉल्यूम. यू आर गोना फाइंड सिमिलर लुकिंग कर्व्स फ्रॉम फॉर प्रेशर वर्सेस वॉल्यूम, ठीक है? उसमें इसमें जो डैश लाइंस है दे रिप्रेजेंट कांस्टेंट प्रेशर लाइंस, राइट, या आइसोबार्स. और अगर हम प्रेशर वर्सेस वॉल्यूम बनाएंगे तो इसमें द डैश लाइंस आर टेम्परेचर वर्सेस, सॉरी, आर कांस्टेंट टेम्परेचर लाइंस, आल्सो कॉल्ड आइसोथर्म्स, ठीक है? ओके, सो मूविंग ऑन. उसके बाद हमने बात की थी फेज चेंज के बारे में काफ़ी डिटेल्स से कि नॉर्मली वी आर ओनली गोना बी एक्चुअली कंसर्न्ड विद द ट्रांजिशंस बिटवीन लिक्विड एंड वेपर, मगर मोर जेनेरिकली all of the things that can happen were discussed. कैचम मेल्टिंग किस तरह हो सकती है, सब्लिमेशन किस तरह हो सकती है. एक पॉइंट जो कि इसमें आया था was के ट्रिपल पॉइंट इज द पॉइंट के जहाँ पे तमाम तीनों फेजेस कैन sort of coexist, and that happens at a particular pressure, and if you drop the pressure to a pressure that's lower than that pressure, then you're going to have to move directly from solid to vapor, a process called sublimation, ठीक है? जो कि कुछ चीज़ों के लिए कॉमन है, मसलन CO2 के लिए, बट कुछ के लिए तकरीबन इम्पॉसिबल है, such as water, क्योंकि ट्रिपल पॉइंट is at really really low pressure, ठीक है? So this is the solid curve that I alluded to at the start of the lecture. जिसको अगर आप टॉप से देखें तो you're gonna find temperature versus volume, side से देखें you're gonna get pressure versus volume, and if you look at it from the other side you're gonna get pressure versus temperature, the three different curves that we studied earlier, ठीक है? All right, so what we wanted to focus on, and this is going to be very important until the end of this course, is going to be reading thermodynamic tables, ठीक है? So ऊपर वाले curves, they give you an idea of the behavior of things, right? But what are going to be the values of individual properties that you are going to get from tables, right? So there were 5 different tables, in fact 4 different tables to focus on. There were 2 tables related to mixed region, जो कि saturated vapor यानी कि liquid, saturated liquid and saturated vapor के mixed region के tables हैं. One of them was sorted by temperature, the other was sorted by pressure, ठीक है? These were tables A3 and A4, A2 and A3. उसके बाद टेबल A4 था जो कि सुपर हीटेड वेपर के लिए था, और A5 था जो कि कंप्रेस्ड लिक्विड के लिए था. साथ हमने बात की थी कि कंप्रेस्ड लिक्विड वाली टेबल में कुछ खास ज़्यादा वैल्यूज है नहीं. Values of these properties often mostly depend on pressure, don't vary all that much with respect to pressure. So temperature is the thing to focus on there, right? Okay. उसके बाद क्वालिटी की बात की गई थी. Remember कि mixed region में, if you look at the tables for the mixed region, they only give you values for saturated liquid and saturated vapor, right? So the idea is कि at saturated liquid, your quality or dryness fraction is 0, right? Because everything is totally wet, right? It's all liquid, there is no vapor. Saturated vapor पे your quality or dryness fraction is 1 because everything is indeed vapor and there are no liquids in it. So the dryness fraction, which is the volume of the gas divided by the total volume, is actually just equal to 1. और बीच में इसकी value is going to go from 0 to 1. And you can find out the value of any of these properties if you have the equality and one other intensive property. ठीक है, स्टेट पॉस्टुलेट यहाँ पे हमेशा इंपॉर्टेंट रहेगा कि आपको दो इंडिपेंडेंट इंटेंसिव प्रॉपर्टीज चाहिए टू फिगर एनीथिंग आउट. सो अगर आपको क्वालिटी पता है, then you can find let's say the specific volume of something in the mixed region by this formula right here, which is V is equal to Vf plus X, which is the quality, multiplied by इसे हम चूंकि चलो टेबल्स में इस तरह तो we're going to use this notation Vg minus Vf, which is the specific volume of the saturated क्या कहते हैं vapor minus the saturated liquid की specific volume. ठीक है. Okay, so the thing to remember, and this is going to be very important in this course, is that you need to have confidence कि अगर आपको दो independent intensive properties पता है तो you can find a third. ठीक है. So if the first problem that we want to solve, and this is from the homework problems जो कि आपको पहले दिए गए थे, is just completing this table, which is just finding values from the table, plugging them in, right? Confidence building in reading the table. Okay, so इसमें सबसे पहले चीज जो देखने वाली है वो ये है कि क्या हमारे पास दो इंडिपेंडेंट इंटेंसिव प्रॉपर्टीज अवेलेबल है भी कि नहीं, जो कि वैसे it's kind of very obvious कि as you can see in each of these rows you've got two things that are indeed available, right? And they are indeed independent. If they were not, और हमें tables को देख के आहिस्ता आहिस्ता शायद पता चलता कि एक second they are not, yeah, this is not enough information here, maybe this is incorrect information, so the tables would reveal that, right? But just from the just from looking at it, it should be sort of clear कि in each of these individual rows which represent like 5 different problems आपके पास दो चीजें available हैं, और चूंकि दो available हैं तो state postulate क्या कहता है कि what, you can find whatever else you need. ठीक है. Okay, so let's do this one by one. अगर let's look at this first one, right? So मेरे पास pressure की value is 200 kilopascal, which you can convert into bars. Remember कि 1 bar is 100 kilopascal, so this is just 2 bars. ठीक है. इसके अलावा और मुझे कुछ नहीं given सिवाय quality के. Quality given है कि 0.7 है. So since we've quality हमें provided है, that means कि we are definitely in the mixed region, right? Because quality is between 0 and 1, so you are definitely between saturated liquid and saturated vapor. So what we need for this is that we need values for Hg and Hf या HFG, ताकि हम H की वैल्यू निकाल सके for that center बीच वाला कहीं का region के जहाँ पे x is equal to 0.7 हो. ठीक है. So एक तो हमें H चाहिए, दूसरा फेज डिस्क्रिप्शन चाहिए थी. फेज डिस्क्रिप्शन तो भाई इस बात से क्लियर होगी कि यार क्वालिटी प्रोवाइडेड है ना, तो दैट मींस यू आर डेफिनेटली इन द मिक्स्ड रीजन. योर फेज डिस्क्रिप्शन इज दैट यू आर इन सैचुरेटेड लिक्विड सैचुरेटेड वेपर मिक्सचर. ठीक है, या मिक्स्ड रीजन या वेट रीजन, देयर आर अ लॉट ऑफ नेम्स एज वी डिस्कस्ड इन क्लास. जो टेम्परेचर होगा, सो नोटिस कि यहाँ पे अगर टेम्परेचर प्रोवाइडेड भी होता और क्वालिटी गिवन होती तो temperature and pressure would not have been independent intensive properties, because the temperature here is just going to be the saturation temperature corresponding to the pressure of 200 kilopascal. Okay, so we have to find all of these using the tables. Or tables may hame, in fact let's just talk a bit more about that. कौन से वाले tables, right? So we've got A2 से लेके A5. The one that we should be looking at is table A2 और A3, one of those two, right? जो कि mixed region में. Now A2 जो थे वो pressure, वो temperature के लिहाज से sorted थे, और A3 जो थे वो pressure के लिहाज से sorted थे, right? So since the thing that is provided to us is indeed pressure, it's better to look at table A3 जो कि pressure के लिहाज से sorted है, and find the pressure of 2 bars. So 200 kilopascal was 2 bars. You're gonna have to look down here, right? So along this line, 2 bar पे, these are all of the values that you should be looking for. ठीक है. Specifically, I guess the things that we are interested in is the temperature, जो कि saturation temperature corresponding to this pressure है. So what that means is कि if you raise the temperature to 2 bars, sorry, if you raise the pressure to 2 bars, water will boil at 120 degrees instead of 100 degrees, right? Higher temperature पे boiling शुरू होगी, which I hope makes sense. Okay, the other thing that we are interested in is actually values of enthalpy, which are these three values right here. Okay, notice that the value in the center is just the difference between these ये right or left वाली values. HFG is just HG minus SHF, right? So ये 2200 की जो value है, this is just 2700 minus 504. Okay, okay. So the thing that we are looking at, the things that we are looking for, and let me just gonna write these values as well, right? The thing that we are looking at is हमें चाहिए values of H, right? So we know that HF is equal to 504, right? Kilojoules per kg, and Hg is 2706.7 kilojoules per kg. HFG is just the difference between these two, which is Hg minus HF, which is 2201.9 kilojoules per kg. जो हमें value चाहिए H की, that is somewhere in the mixed region, right? That you can find that by the formula, which was in the slides, but I'm just going to write it down right here, right? So it's just going to be equal to HF plus X into HFG, which is essentially saying कि हम अगर X 0 होता तो this would have just given me HF, और अगर X 1 होता तो this would have given me HG. और मैं चूंकि ना बिल्कुल लिक्विड पे हूँ ना बिल्कुल वेपर हूँ, मैं बीच में कहीं हूँ, सो मेरी जो H की वैल्यू है, एंथैल्पी की वैल्यू है, that should also be somewhere between these two values, somewhere between 500 and 2700. अगर आप वैसे इसको देखें ना कि आप इमेजिन करें कि you're 70% of the way across from 500 to 2700, right? So that should give you maybe an idea कि अच्छा एक में किधर होना चाहिए, maybe 2200 somewhere around that, right? Maybe मैं उस जगह कहीं पहुंच गया हूँगा, but the math is going to actually give you the right answer. How? It's just going to be equal to 504 plus 0.7, which was the quality, multiplied by the HFG value, which is by 8.9. Okay, and you can calculate that using a calculator, which you should keep handy. So 0.7 into 2201.9 is this much, and just add 504, right? तकरीबन 2045 kilojoules per kg, right? So if you move 70% of the way from 500 to 2700, you get to 2000. The numbers make sense. Okay. So looking back at our question, which should be where? Here, हम कह सकते हैं कि जो temperature है, that is 120 degrees, right? And this enthalpy value is around 2045, and you are definitely in the mixed region. Okay, all right, we can do more problems. I guess I'll make another video for the next couple of problems. Okay, thank you.